Motion capture provides physically realistic character animation. Unfortunately, our captured data may not fit into our desired virtual environment. Path-based editing is a useful technique that allows us to fit a character to a new virtual environment. In this video, we introduce motion tiles, a technique that allows direct, interactive positional control over motion. For example, here we have edited a character to run around the obstacle while still starting in the doorway. Path editing, as introduced by Glacier, allows similar interaction but doesn't work well on all motions. We extend path editing by allowing a user to constrain spline manipulation, as well as introduce a new control called a motion tile that is non-destructive. Our technique considers spline manipulation as a differential constraint problem so that the user can apply any constraint which can be evaluated and differentiated. Here we have no constraints applied to the spline. Notice that the behavior of the spline is similar to standard drawing programs as well as Glacier's path editing. Note also that by stretching the individual spline segments' arc length, the speed of the character in those segments changes due to the fixed spline mapping. If speed changes are undesirable, we can apply arc length constraints. Then if we drag on the last control point in the curve, the rest of the curve follows in order to maintain the curve's original arc length. Bending the curve too much results in implausible motion. By densely sampling and constraining the second derivative's deviation from the original curve, we can limit the allowed bend. Often, an external obstacle restricts the curve's plausible positions. We can constrain the curve to be outside the red obstacle. Then, as we manipulate the curve, it wraps cleanly around the obstacle. Also, we can move the obstacle and push the curve out of the way. We have implemented and demonstrated a small number of constraints. Many other differential constraints are possible and could easily be added to our system. Here we present a motion that could not be edited with path editing as introduced by Glacier. In this example, the character walks toward a position, turns around, and walks away. If we edit the path so the character walks the same way he came, we introduce undesirable discontinuities in the root joint character rotation. The problem is the high curvature area of the motion slides to a low curvature area of the spline as the arc length of the spline changes. With motion tiles, we solve this problem by constraining the high curvature area to remain within a rigid tile. The user marks the inflexible turnaround region as a tile. Then the region can only be rotated and translated. Spline curves are then created for the two surrounding regions. Then we can similarly deform the spline as with traditional path editing. Note that the resulting motion does not exhibit the angle discontinuity. Consider now a more complicated example. Here is a motion of a character who walks to a box, picks it up, and then carries it elsewhere. Suppose we wish to reposition where the character drops the box. To accomplish this, we label the pickup and put down of the box as tiles. We constrain the pickup location and orientation to remain fixed. Note that the tile turns red to signify this. Then, we simply drag and drop the tile to the new position. Notice the adjoining path moves also to maintain the connectivity and arc length constraints. After moving the tile, we can refine the path. In summary, we have introduced a system that allows a user to edit motion's positional properties. To accomplish this, we have provided both constrained spline paths as well as motion tiles. Both these controls can be applied simultaneously to different parts of the motion in order to edit motions that were difficult to treat with previous methods.